this video, we're gonna talk about increasing and decreasing function. We all know that if something is increasing, then it is going up. And if it is decreasing, it is going down. Another way of saying that a graph is going up is that its slope is positive. If the graph is going down, then the slope will be negative. Since slope and derivative are synonymous, we can relate increasing and decreasing with the derivative of a function. First, we have a formal definition of increasing and decreasing function. So first, a function is increasing on an interval if for any x sub 1 and x sub 2 in the interval, then x sub 1 is less than x sub 2 implies f of x sub 1 is less than f of x sub 2. Second is, a function is decreasing on an interval if for any x sub 1 and x sub 2 in the interval, then x sub 1 is less than x sub 2 implies f of x sub 1 is greater than f of x sub 2. So, how does this relate to derivatives? So, recall that the derivative is the limit of f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. If x sub 1 is less than x sub 2, then the denominator will be positive. If also f of x sub 1 is less than f of x sub 2, then the numerator will be positive, hence the derivative will be positive. On the other hand, if f of x sub 1 is greater than f of x sub 2, then the numerator will be negative and the derivative will be negative. This leads us to the following theorem. So, we have theorem on derivatives and increasing and decreasing functions. So, let f be a differentiable function in the interval a and b. Then, number 1, if f prime of x is less than 0 for x in a and b, then f is decreasing there. So number 2, if f prime of x is greater than 0 for x in a and b, then f is increasing there. And number 3, if f prime of x is equal to 0 for x in a and b, then f is constant. So let's have an example here. Determine the value of x where the function f of x is equal to 2x cubed plus 3x squared minus 12x plus 7. So we first take the derivative. F prime of x is equal to 6x squared plus 6x minus 12. To determine where the derivative is positive and where it is negative, find the roots. So, factor to get 6 times x squared plus x minus 2 is equal to 6 times x minus 1 and x plus 2. Hence, the change in sign can occur when x is equal to 1 and x is equal to negative 2. Now, we have our test value and the graph. So, as what we observe, the derivative is positive outside of negative 2 and 1 and is negative inside of negative 2 and 1. We can conclude that f is increasing outside of negative 2 and 1 and decreasing inside of negative 2 and 1. We saw that the values of x such that the derivative is 0 was of special interest. Other points where there could be a change from increasing to decreasing is where the derivative is undefined. We call c a critical number if either f prime of c is equal to 0 or f prime of c is undefined. So let's have another example here. Determine where the function below is increasing and where it is decreasing. So f of x is equal to 2 over x minus 1 plus 18x. F of x is equal to 2 over negative 1 plus 18x. So this will be our solution. Since f of x is not continuous at x is equal to 1, it is also not differentiable there. Hence, x is equal 1 is a critical point. To find another critical points, we take a derivative. It is helpful to use negative exponents instead of fractions here. So we have f prime of x is equal to 2 times x minus 1 to the power of negative 1 plus 18x prime is equal to negative 2 times x minus 1 to the power of negative 2 plus 18 is equal to 0. So 18 is equal to 2 times x minus 1 to the power of negative 2 divided by 2 and multiplying by x minus 1 to the power of 2. 9 times x minus 1 to the power of 2 is equal to 1. Take the square root of both sides. 3 times x minus 1 is equal to 1, or 3 times x minus 1 is equal to negative 1. X is equal to 4/3 or x is equal to 2/3. This gives us 3 critical points. X is equal to 2/3, x is equal to 1, and x is equal to 4/3. This now we construct, or let's construct a table and its graph now to determine positive intervals and negative intervals. So we can conclude, as what we can see, we can conclude that f is increasing for values of x less than 2/3 and values of x greater than 4/3. F is decreasing for values between 2/3 and 4/3, excluding x is equal to 1. A graph of f is shown beside our constructed table. So that's how we're going to define if the function is increasing or decreasing.